Okay, for number 12, I need to write the equation of the table, y equals a times b to the x. The b is my factor, the a is my initial value, but it also multiplies all the values and makes them larger or smaller. We get the initial value on the table by finding the y-intercept, so we'll do that second. The first thing I need to do is find the factor. We find the factor every time on an exponential table by doing y2 divided by y1. Sometimes it's more tricky than that, but we might look at that second semester. For right now, the factor is always y2 divided by y1. So I can pick any y values that are consecutive and call the second one y2 and the first one y1. I could also pick the two values at the bottom and still call them y2, y1. So 21 divided by 42 is equal to 0.5 or 1/2. Either one of those are the same because 0.5 is exactly 1/2. If you had something like 1/3, you would not say 0.3 or 0.3 repeating. You would have to use the fraction 1/3. But these decimals are, this decimal and this fraction are equal, so that's fine. So now I have y equals something times 0.5 or 1/2 to the x. To find the y-intercept on the table, I have to go backwards up the table. So here's 3, here's 2, here's 1, here's 0, and go backwards up the table. The 0.5 works if I multiply it down the table. 42 times 1/2 is 21. 21 times 1/2 is 10.5. 10.5 times 1/2 is 5.25. So if I want to go backwards on the table or up, I need to divide by 1/2 or divide by 0.5. And I'm going to have to do that a few times to get all the way back up to the y-intercept. So I can do this in my calculator and write down the values. 42 divided by 0.5 is 84. 84 divided by 0.5 is 168. 168 divided by 0.5 is 336. And 336 divided by 0.5 is 672, which is my initial value because that's the y-intercept.